Hi, dear children. That day I told you that we will do something on radio reception so that you can do it by yourself also. So now we'll come. Before that, I will just touch something on electromagnetic waves, propagation, and reception, which in the book they have jumped into very technical and difficult topic. Actually, it should have started very qualitatively for the sake of class 12 students. So anyway, drum flute song cannot travel very far. A drum can go to 1 kilometer, a song can be say 200 meters, a flute may be about 80 meters, 100 meters. So this sound wave is this one, this is the time, this is the amplitude. So it needs to be riding on electromagnetic waves which have got very, very high frequency. And these are known as electromagnetic waves and they are called carrier frequency. See, 1000 kilocycles per second. For all India radio with 300 meters wavelength, the frequency of that radio waves is 1000 kilocycles. And this sound wave, say a flute or human voice is only 8000 cycles. So now what we do, we make this to ride on the carrier, and that is known as amplitude modulation. We made this sound wave to ride on the carrier, and see what we get is we get the sound wave in this way. This is known as envelope of sound wave, and this is known as amplitude modulated carrier. It can go thousands and thousands of kilometers, and these are electromagnetic signals. And what is riding over them? A sound wave. And then we will do something to this also. Now, that oscillator I told you is this. See, the radio frequency waves are hitting the antenna, and here is the coil, and here is a variable capacitor. I have told you it is about 30 rupees. Now, so that you'll understand this capacitor variable, see here I have designed this for you. I have designed this. So these are aluminium plate. This is aluminium plate, say, and this is a dielectric. This is a dielectric, and then based on what we have done, the capacitance is Ka by D. So this is D, and the dielectric is the plastic, and now the area is the hemisphere, the semicircular area. Now, if I tune this like this, that means the area will keep on decreasing. See, the area between this aluminium plate and this one, separated by a dielectric, will keep on decreasing. So in this way, I can vary the capacitance. See, this arrow means I can vary the capacitance. So what do? I tune it. See, I want to receive in our college when we did this in 1968, the All India radio was 250 meters, 200 meters wave. So now, where is the thing? Frequency into 250 meter is velocity of light. So frequency is 1200 kilocycles. 1200 kilocycle is the frequency of the All India Radio 250 meter. It is a local station near our college only. So this is the one. Now, what happened now? See, this wave will hit the antenna, and these are the amplitude modulated wave, sound wave, and then we have got carrier frequency. Carrier frequency of this, the one I showed you in the first page. So this carrier frequency. So I tune this capacitor to what? To 1200 kilocycles. So I'll get what signal? I'll get what on all India radio signal, and then it will go to OA79, a diode. Why do we need a diode? A diode here is a detector. Don't mistake with the diode you use in your rectifier, 9 volt, 8 volt, not that. This is high frequency crystal diode. Now, why we need a diode? We want to eliminate either this or this. If we don't have a diode, then 6 microvolt and minus 6 0, 2 microvolt and minus 2 0. So what will come here will get 0. So to eliminate this one before it enters the diode, we use a diode, and I can eliminate, say, I eliminate the negative. When I eliminate the negative, I get the positive. And this positive is what? A sound wave. And what is inside this? These are carrier. This carrier frequency, what do? I told you C is a very good friend of high frequency. So C will bypass all these carrier frequencies to the ground. And what we get? We get finally audio signal, beautiful music or a song you'll get here, and this is your earphone. So see, from this is amplitude modulated. I detected it. That means either I want plus or minus, not both. Both will cancel. So I finally get a beautiful music. This is the music part. This is the carrier. Carrier will be bypassed through a capacitance. And not only that, this carrier will be opposed by the inductance of the earphone. So leave that, capacitance will do the work of filtering all this high frequency. Then we'll get a nice, beautiful music or news or whatever in the earphone. So this is the function of the radio. So this one I think you understand. You have seen with your own eyes. Let me show you again. You have seen this one. See, you can make yourself also. Aluminium, 2 aluminium and 2 plastic. See, this is a plastic. This is a plastic. Then you can have a variable capacitor. So thank you.